This is ISE 453, project number 2. This will be a demonstration of how to use a tool that optimizes the processes given to us in a memorandum. I'm just going to do a quick overview of what the page looks like. These blue tabs at the bottom are business data. The user will never need to reference these unless new data is inputted. This is basically how this tool runs. It references numbers on this page to give us new outputs. There's natural processing times given, machine reliability, line yields, and some batching data. There's an input and output summary page. This is where the buttons are to run some of the analysis. This is also where users can change some of the inputs, such as number of workstations. There's a current reports input, which is used to copy and paste back into this input and output summary, a VBA output, and a tool that gives different references that is achieved by different formulas that we'll talk about later. So what happens when the input and output summary page on tab, when the number of machines changes, data is referenced from the output summary and is used to tabulate data in the tool tab here, and then projected back to the user in the blue box of the input and output summary tab. This keeps users from switching back and forth between tabs, and it keeps the input and output summary page free from lengthy calculations and clutter. Data is scaled into reality using preemptive and non-preemptive outages to make calculations more accurate and help the production manager make more educated business decisions.
So within our tool page, we have some of our formulations. The beginning part of it, with this natural processing time and so on and so forth, and this main part, we get this from the original data given to us in on the blue tabs. It's not until we get farther into the workbook that it starts popping out some of these formulations for us. And then the what-if analysis then can take this information and post it back to the input and output summary page. Now, for instance, if the production manager decides that he has new information, all he has to do is put more information in, and the formulations will take over, will take it into account, recalculate all these, and it can take care of all of it. So all he has to do is just put in new information.
In terms of usability, the user-friendly aspects to this worksheet include the minimal number of inputs needed to manipulate data. The data in the tabs is specific to the action being performed. For example, calculations, inputs, and other data, which is spread out and presented to the user, making it stress-free and easier to understand. The tool lets the user create a theoretical scenario and gives them realistic results by using the VBA output. Going back to the input and output summary page, for example, the inputs shown in yellow of arrival time and number of workstations change the output shown in blue, which is the utilization at each workstation. This drives everything else like the standard deviation, critical WIP, and total line time on the input-output summary page. If the user were to input unrealistic data by maxing out utilization, this would cause the worksheet to give negative cycle times, which essentially means that you cannot realistically work with a utilization coefficient over 1. To teach the user about variability with handling production operations, we'd like to go over its concept. Our tool takes into account the mean time to failure and the mean time to repair to ensure the data outputted to the user is a more realistic model of what actually occurs during production.
So looking at our what-if analysis VBA output tool, we can basically look at, what if we had these characteristics in this different scenario, the scenario specified A through Z, and we can check out the output if we were to run it through our tool using our button here, the Run What If Analysis button. So when it runs through it, we can come back and check here that these cells that were initially empty now have results that have been calculated by our tool and recorded here through use of the VBA code, which will be broken down at another point.
Okay, so we have our two buttons here that correspond with a different VBA code, one to run our what-if analysis on the VBA output page, and one to run current report inputs, which are coming from all of our our observations here and collected here. So let's look at the first one, the first VBA code here, the what if analysis, which is this. So right here. So let's go through the variables. I and j are going to be counters. Whip as double, it's going to be an output. CT is double. RB is double. T naught, 3 naught is double. The worksheet info, which is going to be used to copy and paste, is an array, or workstation info, sorry, as double. K is another counter, and TA is a double. That's another thing that's going to be used to copy and paste. So it says for J 1 to 26, starting this. So so we have 26 possibilities here for where we can put in a what if scenario. And we have our 4 workstation things. The white is going to be input, and it's going to give us back our yellow output. And so it says if our B5 offset range is not empty, then it's going to proceed. So if it's empty, it just skips over this entire thing, goes to the next scenario. So basically, it's keying whether or not to do the scenario based on whether or not TA cell is empty, which makes sense because we can't have a scenario without having a set arrival time specified. So we go on to the next lines here. So it says for I 1 to 4, that's corresponding with the workstation, and for K 1 to 8, that's the cell within the workstation. Basically, what we're going to do is copy and paste this and then put it here and do that for every workstation, and then bring it over and then go on to the next workstation. But just looking at it, it goes K1 to 8. It's going to assign each of these to a different value in the array for the current worksheet's info, and then it's going to transfer them over using that worksheet info, or workstation info, workstation info to right here in these. And then it's going to go on to the next K throughout the array, and then it's going to reset the array for the next workstation to go through that entire scenario. And then it's going to copy over that TA value, that input time, arrival time value, and right here. And then it's going to, using these 2 lines and the variable TA, then it's going to say, okay, so what the worksheet is going to calculate all of these for us. And what the VBA code is going to do is going to copy and paste, or copy every single one of these and put them into the corresponding cell right here. So the total whip, total CT, bottleneck rate, raw process time, and critical whip, which are all calculated for us right here, in these 5. So it just takes those 5 and puts them right there. So that's pretty easy that it can just set them equal there, and then set them equal right there, and just use the next line here to transfer them over. So that's all that button does there. It just runs through all the available scenarios that have been input in there. And then looking at the next one, this is the more optional one, as to where, okay, so I have, like, say I run this, then it'll put in these things, but I want to go back to what my current report says. I can run the current report, and it replaces what's there with this information. And this one's really similar, and just copying and pasting. So it has an array for our information. It has a couple counters, and so it goes through and just does one iteration of what the VBA output did, whatever, 26 times, or however many of these are full. It says, okay, we're going to go into this current report inputs thing, and we're going to assign each one of these to each part of the size 8 array, paste them one by one into here, and do that 4 times, so that it gives us original data. That way we can look at what our current observation is and change our arrival time to look at how that affects our cycle time and our whip, or our critical whip, and such. So that is our code. And, these are great tools to look at what we have and what we can do, and look at the capability of this system, and based on how we change processing times and mean times to failure, and batch times and setup times. So look at what we have and how we can change it to give us our desired result.
An important note, just that the number of machines per workstation on the summary page must be set properly before running the what-if analysis in order to get the desired results, as these values are not specified in the individual scenarios.